Okay, picking up where we left off yesterday. Remind me how we find the vertical asymptotes of this particular graph. Vertical asymptotes. Set the bottom to 0. Okay? So we have to ask ourselves, what is going to make the denominator 0? And one of our first steps is to simplify anyway, right? Okay, so we're going to simplify this guy. So we'll factor the denominator into x and x. 3 and 2 can multiply, or are factors of 6 that can add to get a -1 if we use a -3 and a +2. Okay? Let's factor our numerator and see if anything cancels to make life easier for us. Our numerator is going to have an x and an x, and we need a factors of 2 that will subtract to get 1, so we want a +2 and a -1. So our vertical asymptotes are always the places where the denominator is equal to 0. But what's going to happen in this particular example? They're going to cancel. So we have to remember that we've got to do something where x equals a -2. That's going to be a hole in our graph because we've actually divided it out. Okay. So we know we have a vertical asymptote at what? 3, but don't just say 3 or you're going to lose points. X equals 3. That's a line where x is equal to 3. Okay. Draw it on your graph, dash it in. 1, 2, 3. There's my vertical asymptote. We have to remember our hole at x equals -2. Now, the only reason that we have a hole is because it was going to be a vertical asymptote, but the numerator also had an x plus 2 when we factored it, so those 2 will cancel. We're simplifying first. Okay? That's the only reason we have a hole there. Okay? Now, horizontal asymptotes. If there was something with powers, remind me from yesterday. Then what? If the top is greater, then we're going to have a slant asymptote. Okay? If the top equals the bottom, then it's the ratio, A over B, the leading coefficients, A over B. And if the top is less than the bottom, x equals 0. Or y equals 0. Okay? A little reminder from yesterday. That's for the exponents, yes. When the top exponent is greater than the bottom exponent, the highest power, absolutely. Okay? So we have them equal to each other, right? Since my my highest power of x in both cases is 2, those powers are equal. Therefore, we want A over B. You good with that? So what's my leading coefficient here? 1 over 1. So we know we will have a horizontal asymptote where y is equal to 1. Dash that in. Okay. Talk about the domain here. All real numbers except three, X also can't be equal to our whole, right? -2. Okay. And now let's plot it. Let's do some points. We're going to put an open circle there. Okay. So wherever we happen to be when we're at -2, we're going to have an open circle over here somewhere. So we'll have a smooth curve with a little gap. And then everything else is going to approach its asymptotes. So I always like to plug in 0 to see what happens. When x is 0, like our little t-chart here, 0, 0, -2, right? 0, 0, -6. So -2 over -6, 1/3. So I know when I'm 0 over, I'm 1/3 up. Another nice number to try, 1. So when I put 1 in, 1 squared is 1, plus 1, minus 2. Doesn't matter what's in the denominator, it's going to be a 0, right? Okay. So when I'm 1 over, I am 0 up. Are you convinced enough that it's going to look like this? A hammer line, right? Can't touch this. And -2, when x is -2, we're going to have a hole here. So we make this nice little smooth curve. Comes really close. I shouldn't have drawn it on top of that line. Comes really close to the line but never touches. Okay. Let's try a point to the right. Oh, yep, an open circle at -2. Okay. Now let's plug a point over here in. 1, 2, 3, 4, 5. 5 is going to be kind of a pain. 4 or 5, doesn't matter. Okay. When we plug in 4, 4 squared plus 4 minus 2 over 4 squared minus 4 minus 6. So 18 over 16 minus 10, 9/3, which is, or 9/2, which is 4.5. 3, sorry, duh, 3. It's been a long week. I'm very tired. My brother got married and I haven't recovered. We're up late. I'm not used to staying up past 10 o'clock at night. All right, so we're 4 over, 3 up. Okay, next one. 5. Sure. So we're going to put in a 5, 25 plus 5 minus 2. So there's 30 minus 2 is going to be 28. 25 minus 5 minus 6, 25 minus 11, 14. Well, that's a nice number. When we put in 5, we got 2 out. Nice smooth curve. Okay. So far, so good? Yes, sir. Mm-hmm. And we wouldn't have had to go to the original equation. We could have put these numbers in. I didn't think about that. We could have just said, okay, if x is 5, 5 minus 1 is 4, and 5 minus 3 is 2. 4 over 2 becomes 2. So I should have simplified, used the simplified version of it. Yep. Right. It just emphasizes the behavior. It helps us plot those points. It was a very good question. And we should have just simplified by using our x minus 1 over x minus 3. Again, tired, not mentally working quite right. Okay. If we put 4 in here, 4 minus 1 is 3, and 4 minus 3 is 1. 3 over 1 is 3. A lot simpler that way. Okay. All right. So, ready for a slant. Yep. Oh, thank you, thank you, thank you, thank you. Trying to stop. Okay. The range. Let's think about what y can be. So y is all the way down here, right? Until it hits this guy, -2. So when x was a -2, y would have been -3 over, so 3, oh, we had it right here, right? 2/5, okay? So y can't be 2/5. So it can't be 2/5. And what else can't it be? 1. Can't be 1. So we're going to say negative. You want to see all real numbers or the ranges? 2/5. We said, okay, what happens where we have our whole? When we put -2 in here, -2 minus 1 is going to be a -3, and -2 minus 3 is going to be a -5. So -3/5 is where y was equal, or where x was equal to 2 is y's value. Okay. Did you want to see the interval version of it, or do you want to just do all real numbers except? All real numbers such that y is not equal to 3/5 or 1. Should have been positive 3/5. Okay. Everybody good with those? Kind of, hopefully. All right. Let's talk about slant asymptotes. So your slant asymptote occurs when n, the degree of the numerator polynomial, is exactly 1 more than the degree of the denominator polynomial. Exactly 1 more. So if we have a x squared in the numerator and an x in the denominator, we're going to have a slant asymptote. If we have an x cubed as our highest power of x in the numerator and an x squared in the denominator, slant asymptote. Okay? X to the 4th over x cubed, and so forth. You find it by using long division or synthetic if it's possible. Synthetic's always easier. And the slant asymptote function is the quotient of the division. I don't have to worry about the remainder. And this will make sense when we do an example. Ready? System ready. Okay. All right, so we're going to graph f of x is equal to x squared minus x over x plus 1. The power of our numerator polynomial is exactly 1 higher than the power of our denominator polynomial, so we know that we will have a slant asymptote. And our first step is always to do what? Simplify if possible. Many of you can visually look at this and see that this is going to be an x times an x minus 1, so they will not cancel, right? Okay, so there's no simplifying here. Where's our vertical asymptote going to be? Not just negative 1. X equals negative 1. Don't forget it's a line. Okay. Domain's easy here, right? All real numbers except, what can't it be? Negative 1. Now let's find our slant asymptote. This one we can use synthetic division, can't we? We have an x squared, we have a negative x, and we have no constant. We have to hold its place. We're dividing by negative 1. Show the whole work this time. We're dropping our 1. Negative 1 times 1. Adding these two up. Multiply. It doesn't matter. We're not going to be worried about the remainder. All we're concerned about is these two. So this is now depressed. It's x minus 2. It was x squared. That is my slant asymptote. So if y equals x minus 2, how do we graph that? Slope, right? It's just a line, isn't it? So we start where? Negative 2. Grab. And what's it doing? Up 1 over 1. Rising 1, running 1. Rising 1, running 1. Falling 1, going left 1. So there's my slant asymptote. Okay. Because I pulled my leading coefficients off of here. So this is an understood 1 here, and a negative 1, and then we have nothing at the end. Okay, so I just wrote all those coefficients out. Had to hold the place of anybody that's missing. Yes, sir. We would. And if you did that, you'd get a positive 2, right? And then this becomes 2, but we don't care about the remainder. The only part that we're concerned about is these two guys. So if you want to get lazy and don't even show me that last step, that's okay. You can just put an X through it, and I'll know what you're doing. Okay? Well, we're going to see what happens. Okay? But I think that it's going to, we'll see what happens. That's a good question. I don't think we really mess with a range on with a slant asymptote. Okay, so here we go. Plugging in points. Good point to always plug in. So we're using the numerator, and then we use this negative 1 from the denominator. So that's where this guy came from. Okay, so we are dividing it out like we did before, but we just want to find out what that slant asymptote. And again, it's only when the power is just exactly 1 greater than the in the denominator or in the numerator than the denominator. Okay. All right. So now we're going to pick some good points. X is 0. 0, 0, doesn't matter. 1, we're going to be at 0, aren't we? So let me make my little chart here. Okay, what's another good number to try? 1. 1's an easy number. 1 squared minus 1, still going to be 0, isn't it? So we're 1 over, we're 0 up. Don't want to try 2 because that's an asymptote, right? Slant asymptote. So can you see what's going to happen here? To try negative 1/2. Negative 1/2 squared. Negative 1/2 is negative 1/2 is going to be a positive 1/2, and negative 1/2 plus 1. So 1/4 and a half is 3/4. 3/4 divided by a half is going to be 3/2, 1.5. So at negative 1/2, we're 1.5 up. So can you see what it's doing there? Yep. I'm going to approach this asymptote, but never touch it. Approach this one, never touch it. Okay. And what's another good number to try? Negative 2. We're going to see what happens over here. When we plug negative 2 in, negative 2 squared minus a minus 2 and negative 2 plus 1. So 6 over negative 1 is going to get me negative 6. 2 back, 6 down. You want to try 7? Or try negative 3? Or are you okay with this? Going like so. And like so. Very good. That's a slant asymptote. All right. So the rest of your assignment, finish it up. We're at 9 through 15 odd, 17, 26, 27, 29, 33, 57, and 60. Okay. Slant is one, the numerator has a 1 higher power than the denominator. Equal is the coefficients. And if the denominator is greater, then it's going to be y equals 0, the x-axis.